Good morning, everybody. Welcome to Wednesday morning, cloudy and overcast, Wednesday morning, a Chem 11:05 with your host, me, Dr. White. Hi. All right. Important things I like to mention. First of all, the lab I talked about yesterday, balancing chemical equations, I'd like you to hand it in by Friday or Saturday. The balanced chemical equations, I'd like to have you hand it in by this Friday or Saturday, because that way I can grade it, get it back to you before test two, and you can see how you've done. Now, speaking about test two will be 2 weeks from today. It will be online, just like test number one. And it will cover chapter 4 and chapter 5, part 1 through, I think, 4. I'll put out by the end of this week an announcement and email about test number 2, how many pages, what area, topics, etc. I should warn you, historically, test number 2 has been the lowest average, but not always, but a lot of the times. So do the practice problems and you'll do good. Now, speaking about practice problems, today I'm going to go through chapter 4 practice problems. On Monday, speaking about before we go into practice problems, if you look on your screen, you'll see the academic calendar for College of DuPage. Today's the 22nd. Next week is spring break, which means there'll be no lectures, no labs, and no office hours for Dr. White. I'll still check my email probably once a day from Monday the 27th through Friday the 31st. Again, it's spring break. But when we come back after spring break, let's look at Blackboard. Let's go into course information, recommended problem sets. If you notice, there's 1, 2, 3 parts for chapter 5, part 1. I split it up that way. All right, on the Monday, when we come back, I will go through practice problems, chapter 5, part 1, balancing chemical equations. That same day, I will go through on that Monday when we come back after spring break, practice problems, chapter 5, part 1, mole problems, part 1. Yep, there's a lot of stuff in chapter 5, part 1. Again, on Monday, when we come back, I'll go through chapter 5, part 1, balancing chemical equations, practice problems, and I'll go through practice problems, chapter 5, part 1, mole problems, part 1. On Tuesday, after we come back from spring break, I will go through practice problems, chapter 5, part 1, mole problems, part 2. I'll do the mole problems, part 2 for chapter 5, part 1 on Tuesday. And that way you should be prepared for test number 2. All right, let's go through chapter 4, practice problems. And let me make this a little smaller. There we go. Number 1, draw the Lewis structure for the following elements. Remember, drawing Lewis structures for elements and compounds are a little different. For elements, you should have one dot on each side before you double up. Again, you should have one dot on each side before you double up. And the Lewis structures use valence electrons. The Lewis structure uses valence electrons. So if I ask draw the Lewis structure for sodium, the first thing you have to do is go to your friendly neighborhood periodic table and say, how many valence electrons does sodium have? And how do you find that out? Nope, you don't drink some water. You go to the top of the column of the periodic table and look for the number 1. That means sodium Na has 1 valence electron. And there are 4 different ways you can do it. Here's one way on the answer sheet. One side, any side has 1 dot. Now, we look at carbon, the Lewis structure. How do you do it? Lewis structures are valence electrons, 1 dot for each valence electron. Carbon C, look on top, see the number 4, and therefore it has 4 valence electrons, and you put 1 dot on each side. It would be wrong if you put 2 dots on one side for carbon. Now, if we look at oxygen, what's the chemical symbol for oxygen? O. And if we look here at the top of the column for oxygen, you see the number 6. Therefore, oxygen has 6 valence electrons. That's something I'll never do again. Anyways, how do we do that? 1 dot on each side, and 2 sides have 2 dots. Now, organic chemists always put 2 on top and bottom. You can do any side. 2 sides can have 2 dots, and 2 sides have 1 dot. Next, let's talk about what ion does the following element form. And let's do magnesium. How do you do that? Well, you have to look at your periodic table. Magnesium is at 12. To form an ion, that element wants to have the same number of electrons as the nearest noble gas. To form an ion, that element wants to have the same number of electrons as the nearest noble gas. Nearest is defined as closest numerically. Closest numerically. Wow, I'm doing a lot of special effects today. But anyways, that's how you do it. So you have 2 choices. Magnesium, 12. It can go to argon, 18, 6 away, or neon, 2 away. Which is closer? Hopefully you pick neon. So magnesium has 12 electrons, 12 protons. But to form an ion, it wants to have 10 electrons. It never loses protons. I've never done anything in chemistry that lost a proton. It shouldn't. It doesn't. Well, there are 10 electrons. The charge on each electron is a -1. There are 12 protons. The charge on each proton is a +1. Do the math. -10 plus 12. Add them together, you get a +2. Now the question asks, show or write the ion. and you do that by the chemical symbol, then superscript right, you put the number you get here. Now, I like the old way. The newer way, which I don't like, but you can do on my test, is this way. And that's your answer, not +2. You also have to have the symbol. Oh, let's do another one. These are fun. Oh, I got it right. Yay. All right, let's do oxygen. And oxygen has an atomic number of 8. Which means it has 8 electrons, 8 protons. What's the nearest noble gas? Neon is 2 away, helium is 6 away, and argon is 10 away. What's the closest? Neon at 10. Wow, we're picking on neon today. So oxygen is at 8 electrons, 8 protons. It wants to have the same number of electrons as the nearest noble gas, neon, which is 10 electrons, but you don't change the protons. Still have 8. Now, each electron has a -1 charge. There are 10 of them. Each proton, 8 of them, has a +1 charge. Do the math. Add them up together, and you get this. The question asks, what ion does oxygen form? And you write the ion chemical symbol, and then this number superscript right. Now you can write it the old way, which I like, or the one I don't like, but I will mark it correct on a test that way. And that's how you calculate or determine what ion an element will have. Next, what is the empirical formula, the chemical formula for a molecule formed from the following ions? And the key to this is, oh, I better be subtle. And know this. And what should you know? All molecules have a net zero charge. All molecules. So if I ask, what is the empirical formula for a certain set of ions, how do you do that? Well, if we look at sodium as a +1, bromide ion, Br minus, so -1, well, that adds up to 0. So if there's one of these, the formula, empirical formulas, oh, excuse me, NaBr. Let's do calcium chloride. And the question is, what's the empirical formula with calcium +2, chloride +1 ion? Well, this is a +2, This is a -1. You cannot change these numbers, the charge of the ion, but you can change how many. Remember, know this, all molecules have a net zero charge, which means this has to add up to 0. Well, it doesn't. How do you make it add up to 0? If I have 1 calcium and 2 chloride, it will be 0. How do we show that? 1 calcium and 2 chloride, and that's calcium chloride. By the way, we've been lucky this winter. I should keep my mouth shut. We haven't had really that much super cold. And those little white pellets you get from the home improvement store in 50-pound bags that do a better job of melting ice on your driveway when it's super cold is calcium chloride, CaCl2. Oh, let's do another one. Let's do lithium plus oxygen -2. And the question is, what's the empirical formula for these a molecule with these ions? Well, lithium is a +1, oxygen is a -2. Remember, know this, all molecules have a net zero charge. Well, that means this has to add up to 0. Does it? No. This is a -2, this is a +1. Students want to, but you can't change the charge. You can change how many. To get to 0, if I have 2 lithium and 1 oxygen -2, now it will be 0. And how do you write the empirical formula? Well, this tells me there are 2 lithium. And that's how you write that. And 1 oxygen. And that's lithium oxide. Let's do one more. And that's, oh, let's do E. Calcium +2 bicarbonate of polyatomic ion. The whole thing has a -1 charge. So what's the empirical formula for a molecule with a +2 calcium and a -1 bicarbonate? Well, this is a +2 charge. This whole thing here is a -1. As you know, all molecules have a net zero charge. Know this. And this has to add up to 0. Oh, it doesn't. Well, this is a +2, and I can't change that number, but I can change how many. Now it adds up to 2. So this tells me I have 1 calcium and 2 bicarbonate. When you have a polyatomic ion, and there's more than one, like 2, 3, whatever, you put it in brackets. And then subscript to the right, whoop, down there, we want 2, so I'm going to put a 2. Again, when you have more than one polyatomic ion, you put it in brackets, and then the number you have of that is to the right subscript. And let's continue on. Now, next, draw the Lewis structures for the following. And let's do ammonia. And how do you do that? You first have to find out how many valence electrons hydrogen has, because it's NH3, 3 hydrogens, and nitrogen has. If you look at the periodic table, hydrogen has 1 valence electron, nitrogen has 5. So hydrogen, 1 valence electron, nitrogen, 5 valence electrons. Now, the easiest way, draw the Lewis structure. For nitrogen, hold on, doesn't look like an N. That's better. Now there are 3 hydrogens. And remember, excuse me, when you're forming a molecule, you want each element to have an octet, 8 valence electrons, its own, non-bonding, and shared bonded electrons. And if we look at this, nitrogen has a pair up here, but 1, 2, 3 unshared electrons. Each hydrogen has 1. So this hydrogen says to the nitrogen, I've got an unpaired electron. You do, let's share. And they do. This one does the same thing. And this one does the same thing. That should be 1 dot. That should be 1 dot. Now, the octet rule, all elements except for hydrogen, hydrogen exception. The octet rule for hydrogen is 2. The octet rule for hydrogen, 2, 2, 2. And if we look at this structure, this hydrogen has 2 electrons, shared or unshared. Same with the others. Now, if we look at nitrogen, count the dots, 2, 4, 6, 8. It has its octet. And that's how you do it. Now, let's do another one. Nitrogen gas. Right now, as you inhale, 80% of the weight of the air you're inhaling is nitrogen. And it has a chemical formula, N2. Draw the Lewis structure for nitrogen. Well, we just learned nitrogen has 5 valence electrons. And this nitrogen says to this one, hey, I've got 3 unpaired electrons. You have 3 unpaired electrons. Let's share. And they do. So the non-bonding electrons on top are still there. But we had 1, 2, 3 pairs. And now, let me write this better. Let's check, does each nitrogen have an octet? Well, this one has 2, 4, 6, 8. Yes. And we'll look at the other nitrogen. That has 2, 4, 6, 8. And guess what? We're done. But it's time to talk about covalent chemical bonds. Remember, you should know covalent chemical bond is sharing of pairs of electrons between two atoms. Sharing pairs of electrons between two atoms. And you should know, ooh, it's subtle time. And know this. And what do I want you to know? The covalent bonds. Let me change my mind on this. Instant chart. First type of covalent bond is a single bond, and that's one pair of electrons. Second type is a double bond, and that's two pairs of electrons being shared. And the final one is a triple bond, and that's three pairs of electrons. You should know the names of the three types of covalent bonds: single bond, double bond, triple bond. You should know how many pairs of electrons are being shared in each bond. Single bond, one pair of electrons. Well, I'm getting serious. Well, it says, hint, know this. Single bond, one pair of electrons. Double bond, two pair. Triple bond, three pair. And if we look at ammonia, NH3, what type of covalent bond exists between the nitrogen and hydrogen in that molecule? And the answer is one pair of electrons. Therefore, by the way, these three dots, like this means in math, therefore, it's a single bond. What type of bond, covalent bond, exists between the two nitrogens in nitrogen gas that you're breathing in now? Three pair of electrons? Oh, look, it's a triple bond. And you should know this. See, it even says it on the screen. Oh, that was bad. All right, let's continue on. And let's do H, sodium hydroxide. And what's the question? Draw the Lewis structure for that. Now, first of all, we have to know sodium has one valence electron, hydrogen has one valence electron, and oxygen has 6 valence electrons. Now, listen closely. This is important. all alkali metals and alkaline earth metals, lithium, sodium, potassium, magnesium, and calcium, never, ever form covalent bonds. They always are in ionic bonds, meaning they give up electrons. Remember, all alkali metals and alkaline earth metals, lithium, sodium, potassium, magnesium, calcium, form ions. The alkali metals form a +1, the alkaline earth metals form a +2. So let's draw the old name for sodium hydroxide is lye. That was used to make soap, and it's used a lot in the chemical industry for other things. All right, so sodium has one valence electron. Hydrogen has one valence electron, and oxygen has 6 valence electrons. Now, oxygen has 6 valence electrons, hydrogen has 1. And the oxygen says to hydrogen, oh, I've got 1, you've got 1 valence, let's share. And they do. Now, the sodium will form an ion. What ion? We've done this, a +1. Are we done? No, because if you look here, oxygen only has 6 valence electrons, 7. Yeah. So let me start that again. I'll wind it up backwards. Nope, 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 nope. If we look here, oxygen only has 7 valence electrons. It's 6 plus the 1 from hydrogen, because it's shared. Well, how does it get its octet? Well, what happened to the electron from sodium to form a +1 charge? Because it had a valence electron. Now it doesn't have that 1. It goes here. And now oxygen has an octet, but it has an extra electron, so it has a minus charge. And the hydroxide anion, OH minus, is in a ionic bond with the sodium cation, Na plus. The oxygen and hydrogen have a covalent single bond, 1 pair of electrons. And you should know how to do this. Remember, all alkali metals, lithium, sodium, potassium, are always an ionic bond, give up an electron. Magnesium and calcium, same thing, give up 2 electrons. And finally, number 5, name the 3 types of covalent chemical bonds: single bond, double bond, triple bond. What I didn't have here, but I should, so let's go through it again. You should also know for each of the 3 types of covalent bonds, how many pairs of electrons are being shared. You should know. See, it says it right here. Hint, you should know. Name the 3 types of covalent chemical bonds, and you should know how many pairs of electrons are being shared for each type. Single bond, 1 pair. Double bond, 2 pair. And triple bond, 3 pair. And we're done with Chapter 4, Practice Problems. Now, I'd like to remind you, as you learned from test number 1, what is the reason I call them practice problems? Hint, hint, wink, 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 say no more. Or I think it's hint, hints. No, it's hint, hint, wink, wink, say no more. That's from Monty Python show. You've never seen any of them. You're missing some of the best comedy in all of television ever made, or anything ever made. It's great. It's an English show that was on in the late 1970s here on Channel 11. And I remember it was at 11 o'clock or late at night, but I'd always watch it. So did all my friends. Well, anyways, I call them practice problems, and you learn, and you'll learn again after test number 2, why they're practice problems. Now, if I look at the clock, I think this is a good time. Let's take a 5-minute break. I'll be back in 5 minutes, and we'll continue on. See you in 5. I'm going to get up and stretch. I'm back. Hopefully you are too. All right, let me remind you, next week is spring break. You notice the week of the 27th through the 31st of March. Oh no, I just remember. I won't be able to do my famous April Fool's Day jokes. They're not that famous, and you're lucky you're missing out on them. Oh no. But anyways, next week from the 27th through the 31st, I think it starts officially on that Sunday or Saturday. I think that's Sunday. But anyways, that week we will not have class. Spring break. Yay. By the way, if you're going somewhere nice, email me a picture where you are, and you might say in the email, having a great time, glad you're not here, or something else, whatever. But anyways, you don't have to do that. But there will be no lectures, no lab, no office hours next week. But I will check my email at least once a day. Don't forget, when we come back, we'll come back the week of the 3rd, April 3rd. On the 5th, I will be giving test number 2. Almost said 3, no, test 2. And on Monday, I'll go through the balanced chemical equation practice problems for chapter 5, part 1, and I'll go through the mole practice problems, part 1 of chapter 5, part 1 on Monday. On Tuesday, April 4th, I will go through the mole part 2 practice problems for chapter 5, part 1. And like I said on Wednesday, I will give test number 2. I'll send out the password after we're done with Wednesday's lectures, and you'll have until the next day, I don't know, 1 p.m. or somewhere around then, to take test 2 and upload test 2 to me in Blackboard as a single PDF file. All right, let's get back to what we were talking about yesterday. First of all, let me find it. Now, I was talking about the coefficients in a chemical equation give fixed molar ratios between the reactants and the products in a chemical equation, a reaction. And we went through mass or weight calculations where you need to do 3 steps. The important part of that to remember, 1 mole of A, if it's a compound, equals the molecular weight of A. And the coefficients of a balanced chemical equation represent molar quantities. Again, this is given to you in important information, test number 2. The 3 steps are right here. So let's do one more practice problem, because this one's something you should practice a lot, and we will. Yep, 10 points. You will be given for this problem a balanced chemical equation. For this one, it would be this equation. And the problem is how many grams C3H8, that's propane, the stuff in the white tanks for your barbecue, all right, so the question is, given this balanced chemical equation, how many grams, G is grams, of C3H8 propane are needed to react with an excess of oxygen, O2, to make 7.13 times 10 to the third grams of CO2, carbon dioxide. So, first thing, I'm going to give you a chance to do some of this. What are we being asked to find? What are we given? Your turn. Again, what are we being asked to find? And what are we given? I'm going to share the fun today. All right, let's do this. Well, we're asked how many grams of propane. So we're being asked to find how many grams of C3H8. What are we given? Well, as soon as you see an excess of something, you can just forget about it. I did. But to make 7.31 times 10 to the third grams of carbon dioxide, CO2. And now once we have this, plus the balanced chemical equation, we don't have to look at the word problem anymore. Now, if you look at this, we're trying to go from grams to grams, and you can't do that in one step. You need 3 steps. And where do you find those? In the past, students in my class had to memorize this. Good news. All you have to do now is look at important information, test number 2, mass calculations for reactions. And here are your 3 steps, 1, 2, and 3. Step 1, convert the mass of A to moles of A. Remember, mass means grams. Then in step 2, the moles of A you just calculated, use here to convert to moles of B. And now in step 3, the moles of B you calculated in step 2, you use in step 3 to calculate the mass of B. Now, what's A? A is whatever you're given in weight. That's the compound. What's B? Whatever you're trying to go to. So let's take a look at our problem. So we need 3 steps. And what's A? Well, the only thing we have is this number. And A is carbon dioxide. And we want to go to what? Moles of A. A is carbon dioxide, so moles of CO2. And what units go on top and bottom of that ratio to convert this? I'll let you have some time to figure out the units first. Use your good buddy, your good friend. Your turn. And let me remind you, and I'll put out an email, try and get the balanced chemical equation lab handed in by this Friday or Saturday. Let's say it's Saturday. All right. It's time to use your good buddy, your good friend, unit analysis. And whatever we're trying to get to goes on top of the ratio, unit-wise. Whatever we're trying to get rid of, we don't want those units in our answer, we put at the bottom of the ratio. And this would be moles of CO2, grams of CO2. And where do we get a relationship of grams of a compound to moles of a compound, or moles of a compound to grams of a compound? Important information. Test number 2. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights in that compound. Well, now we need to find out the molecular weight of carbon dioxide. Now it has carbon, so you need the atomic weight. Remember on test 2, it will say under your name, please use proper significant figures for all calculated answers. And it will also say, please use three significant figures for all atomic weights. And carbon to 3 significant figures, 12.0. Oxygen, 3 significant figures, 16.0. So for every 1 mole, we need the molecular weight of, in this case, CO2. It has 1 carbon and 2 oxygen. 1 times the atomic weight of carbon, 2 times the atomic weight of oxygen. Do the math, add it up, we got 44.0, and you get the same number of significant figures to the right of the decimal as the number that has the fewest to the right of the decimal when you're adding. And this has 1, this has 1. Oh, our answer has 1. We don't have to round it off. And that's where I get the 44.0. 1 mole of a compound equals its molecular weight. Now, if you notice, grams divided by grams of CO2, anything divided by itself equals the number 1, meaning it cancels out. And we're left with moles of CO2. So now I'll pick up my calculator. And have 7.31 blue double E, that's how I get the third, times 10 to the third, divided by 44.0. And my calculator gives me this huge number, huge being number of significant figures. I'm not going to write all of them. There's some more, but this is enough, times 10 squared. Now, remember, when you have a multiplication division like this is, both multiplication and division, your answer has the same number of significant figures as the number that has the fewest significant figures. So if we look at this, this is 3 significant figures. All non-zero numbers are significant. The 1 is an exact number, plays no role, and 44.044. Now, any zeros after a decimal are significant, so this has 3 significant figures. And now you round this off to 3 significant figures. Keep the 1, keep the 6, keep the 6. The next one, the 4th significant figure used to round off, is that 4 or less or 5 or higher. And time's up, it's 4 or less. So we drop all that. And the correct answer for this step is 1.66 times 10 squared moles of CO2. And this is step number 1. Are we done? No, we need 3 steps. And the answer has to be grams of C3H8 propane. So we now have to do step number 2, and that's moles of A to convert to moles of B. Now, A is what we just calculated, 1.66 times 10 squared moles CO2. What's B? Well, if we come up here, it's what we're trying to get to, propane. But in this case, not grams, we're trying to get moles. So if I have a ratio, I want to get to moles propane, C3H8. And now what units go on top and bottom of that ratio? Your turn. Boy, this is thirsty work. Please be patient. I try and give everybody time to finish. Finish. And you know what's coming up, don't you? Yep. All right, my turn. It's time to use your good buddy, your good friend, unit analysis. And how do you do that? Whatever you're trying to get to, the units go on top of the ratio. Whatever you're trying to get rid of, the units go underneath. I'll write that in. Moles of C3H8 goes on top. Moles of CO2 go underneath. Where do I get those numbers? Well, you come up to the balanced chemical equation, and the coefficient, the number in front, when there's no number, it's the number 1. I'm trying to get the relationship between moles of propane, C3H8, and moles of CO2. And if we look up here, the coefficient in front of propane is a 1. That tells me 1 mole of propane makes, in front of CO2, 3 moles of CO2. Also, 5 moles of oxygen react with the 1 mole of propane to make the 3 moles of CO2 and 4 moles of water, but oxygen, water, we're not interested in this problem. And therefore, remember the coefficients of a balanced chemical equation. And when there's no number, it's the number one. Tell you molar relationships. 1 mole of C3H8 propane makes 3 moles of CO2, carbon dioxide. So 1 mole of C3H8 makes 3 moles of CO2. And that's where we get these numbers from the coefficient of the balanced chemical equation. The propane number in moles of propane come from the coefficient 1. The carbon dioxide moles, CO2, comes from the coefficient of the balanced chemical equation, 3. And now before I pick up my calculator, notice moles of CO2 divided by moles of CO2. Anything divided by itself equals the number 1, cancels out. This cancel out, we're left with moles of propane, which is what we want. So now I'll turn on my calculator. 6.22 blue double E2 divided by 3. Oh, my calculator gives me this number. And again, you get the same number of significant figures in your answers as the number you're multiplying, dividing, that has the fewest significant figures. How many significant figures here? Your turn. All non-zero numbers are significant. 1, 2, 3, 3 significant figures. Coefficients, the 1 and 3, which we got from here, are exact numbers. Coefficients, the 1, the 5, the 3, the 4, in any balanced chemical equation are exact numbers. Therefore, this is an exact number, and so is the 3. And that means they play no role in how many significant figures your final answer has. So the only number we have to go by is 3, and therefore this should have 3 significant figures. And I'm going to give you a couple of seconds, more than 3. Oh, how'd you like that? Never mind. But how many? Round that off to 3 significant figures. Time's up. Keep the 5, keep the 3, keep the 3. That's my 3 significant figures. Use the next number, a 3 again, to round off. Is that 4 or less or 5 or higher? And hopefully I'll pick 4 or less. So I'm going to drop this. And the correct number for this step number 2 is 5.33 times 10 to the first moles of C3H8 propane. Are we done? No, we want to get grams of propane. So now, as it says up here, you need 3 steps. Well, we've done step 1, we've done step 2. It's time for step number 3. Now, when you're doing this on a test, you're going to go faster. I'm going super slow so you can follow what am I doing, and you can get it right too. And step 3 is moles of B to grams of B. And if you don't believe me, you should, but just in case you don't, There it is in writing. Moles of B, step 3, the mass, which is grams of B. So how do we do that? Well, the number we have to start with, moles of B, remember B is propane, C3H8. What do we want to get to? Grams of B, and B, as I said, is propane. Now, what goes on top and bottom of that ratio? The units. Your turn. Use your good buddy. And for those of you who are watching the video, if you need more time, just press the pause button or actually click on it. Unless you have a touch screen, then you can press it. I don't on my monitor for this computer. My tablet, yeah, but not my computer. Again, what units go on top and bottom of that ratio? All right, let's do it. And you know what's coming up? Yep, it's time to use your good buddy, your good friend, unit analysis, and it has been mine for many, many, many years. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath, and we're talking about the units. And where do I find a relationship between grams of a compound and moles of a compound? Well, in case you forgot, hopefully you haven't, but if you did, test 2, important information. The last page of the test file I sent to you or you print out will have this whole page. And notice 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight is the sum of all atomic weights. So what does that mean? It means 1 mole of a compound equals the molecular weight, MW. Well, we need the molecular weight of propane. And propane has 3 carbons, 8 hydrogens. And now I have to look at and find the atomic weight, the 3 significant figures for wrong button for carbon and hydrogen, the 3 significant figures. Hydrogen is 1.01. Carbon to round 12.011 to 3 significant figures is 12.0. So there's 3 carbon, each one is 12.0. There are 8 hydrogen, each one is 1.01. I was getting ahead of myself. 1.01. Do the math, 3 times 12.0 is 36.0. 8 times 1.01, 8.08. Now we add it up. And this is what we get when we add these two numbers up. Now, when you do an addition, you get the same number of significant figures to the right of the decimal as the number you're adding that has the fewest significant figures to the right of the decimal. You don't touch the left, just the right. This has one significant figure to the right of the decimal. This has two. Your answer should have the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right of the decimal. And if we look here, we're talking about what's the lowest number? 1. So we keep the 0. That's my first significant figure. And the next one we use to round off. Is that 4 or less or 5 or higher? And time's up. That's 5 or higher. I drop that, and the 1 in front I increase by 1. So the correct answer here is 44.1, which means the molecular weight is 44.1 grams per 1 mole. Now, before I pick up my calculator, don't pick it up yet, I check moles of C3H8 divided by moles of C3H8. Anything divided, I don't want to do it there. Remember, anything divided by itself equals the number 1, meaning it cancels out. This cancels out. I'm left with grams of C3H8. And now I can pick up my calculator. Put in 5.33, blue double E, 1, oops, wrong number, 1 times 44.1. And my calculator gives me this number. And I'll let you figure out what's the proper number here using significant figures for a multiplication division. Your turn. All right, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the fewest significant figures. 1, 2, 3, 3 significant figures. 1, 2, 3, 3 significant figures. This number 1 is an exact number. Therefore, when you multiply and divide, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the lowest significant figures. Both are 3, so we round this off to 3 significant figures. Keep the 2, keep the 3, keep the 5. That's my 3 significant figures. Use that to round off. And is that 4 or less? Yes, I'm going to drop that and that. And the correct answer is 2.35 times this one we dropped 2 times 10 to the third grams of propane. Now, as I mentioned yesterday, when you do multiple step calculations like this is 1, 2, and 3, there are 2 ways of rounding off. One is round off at each step, and I'm a round off at each step person, or round off at the end. Now, when I do these problems here in class, I just do round off at each step. But on the test, I will calculate both ways. I do it on a spreadsheet. And also the practice problems, I do it both ways. And I'm not going to force you to round off the way I do in terms of multiple step, because they're usually close or very close. So on problems on a test like this, there's a potential, if it's not identical, which it is sometimes, but it's different, there could be two different answers. Now, this is 10 points. Yep, 10 points. If you were just to put an answer down here and it's wrong, you get 0, zip, 0. But if you show your work, you get partial credit. What if in step 2, you put the 3 on top and the 1 on bottom? I've seen students do that, this type of problem. I'd say, you made an error. Well, that's important, but the rest of it you got right. I would give you maybe 7 points out of 10 instead of 0. That's a big improvement. If you made a math error somewhere along the way, you had, say, step 1, you have this correctly, but the number here you got, I don't know, let's say, just for example, I'm pulling it out of my head, see, 5.72 times 10 to the third moles of CO2, which would be wrong. But you pressed the buttons wrong on your calculator. Well, that's a math error. You did everything else right, carrying that wrong number along. I would say, math error, 10 points, I'll just take off 1 point. And that's how you do this. Now, interesting thing I should talk about. When I worked in the chemical industry, and part of my job at my level was to write procedures. How much of each chemical you mix together and the conditions too to make a product. Not only to make a product, but to make the number of pounds that a customer wants. And usually it was either 40,000 at one company per batch, that's a whole tank wagon, or at another couple companies, it was a lot larger. One company, the final amount of products you would make or product would be about 160,000 pounds. And $1 a pound in chemicals plus labor costs, you're talking almost $200,000 in costs. Rely on that calculation, the 3-step being correct. And what I would, and if you got it wrong and you blew that amount of money, guess what? You'd probably get fired. I never did. How did I do that? I do the calculation on one day far enough in advance, and then I'd wait 2 or 3 days and redo it fresh without looking at the first calculation I did. Then I'd pull it out of a folder wherever I kept it and look, and they better be the same. Or somewhere I made a mistake. They're always the same because I took my time and I always use, I got to do it. My good buddy, my good buddy, my good friend, unit analysis. And that was fun doing procedures. Plant manager would call me up and say, we need this, or a lot of times once you did it once, they kept it in their files. The first time they would run a new reaction that I invented, I'd go to the plant and personally supervise that they did it correctly. And it was fun going to chemical plant. All right, let's continue on. Now, click, the switch is off. There's an important concept called percent composition. And that's the mass of percent, a percent mass really, I should have that, of each element in a compound. And how do you calculate that? Remember, click, switch is off. This won't be on a test or the final, but I do want to mention it. And that's the mass of each element divided by the molar mass, how many, the grams per mole times 100. And that's called percent mass of each element. Now, interesting story. At least I hope you find it interesting. When you're an organic chemist and you make new molecules, especially for your PhD thesis, an important analytical measurement is the percent carbon, percent hydrogen, percent nitrogen in that compound. That's called percent CHN test. And you send that out to a laboratory that does that. But you have to have ultra pure sample to send them to get percent CHN. Well, each time you have to get an ultra pure sample, it takes a lot of time. For my PhD thesis, it's been a while. I think I had over 150 new compounds I made for my research, which means I had 150, more than 150 CHN analysis percent composition of that element, in this case, carbon, hydrogen, nitrogen in each compound. And that helped identify the new compound. And boy, was that a lot of work. But it was for a good cause, my PhD thesis, me getting a PhD. All right, let me remind you a couple of things, because we've done a lot today. One, next week, spring break. I hope you all have a nice spring break. Guess what? You can take a break from Dr. White. However, if you're getting a Dr. White withdrawal symptoms, you can binge watch my videos on YouTube. I don't know about that, but you could. All right, seriously. Next week will be spring break. When you come back, the Wednesday we come back, and I'll be posting an announcement and sending out an email about test number 2, which will be taken on Wednesday after we come back from spring break. And you'll have until Thursday, just like test 1, you had until next day. Take test 2, upload your answers as a single PDF file. I will also remind you, the balanced chemical equation lab, I'd like you to hand in by Friday or Saturday so I can grade it and you can see how well you do. Because on test 2, I promise me, I've never, ever broken a promise to myself. And I'm very careful what I promise myself because I know I won't break it. There'll be at least 3 problems where you have to balance a chemical equation, 3 points each. There will be. Also, hint, the problem we just went through, you should know how to do. Hint. But anyways, also, don't forget, yesterday you should have handed in the lab that was due. Next week, you don't have to hand in the determining chemical reactions and physical changes, or whatever the title was. That's due 2 weeks from yesterday, because that I won't ask you to hand in during spring break. Well, wait. And don't forget, tonight, if you have any problems, I have my office hour from 6 p.m. to 7:15. And with that, I'm going to say goodbye because I'm done for today. We're going to let you out. Don't tell the dean a couple minutes early. Shh. Don't tell. Actually, I don't even have to do this for net class, but I do because that helps you do better in my class. And it makes me feel so good. See, I feel good thinking about all the students doing good in my class. Study, do the practice problems. When we come back Monday, we'll go through Chapter 5, Part 1, Balanced Chemical Equations. Monday after spring break, when we come back, we'll go through Chapter 5, Part 1, Mole practice problems part 1. Tuesday, after we come back from vacation, we will, or not vacation, spring break, we will, I guess it's vacation too. We will go through on that Tuesday, chapter 5, part 1, mole practice problems, part 2. Yeah, there's a lot of practice problems for chapter 5, part 1, because you need it. It helps you do good. And with that, I'll say, have a great spring break. If I don't see you tonight in my office hours. And with that, I'll say, gang gesund, goodbye. Stole that from Granny to Beverly Hillbillies. Bye.